Ever wondered why a body becomes stiff after death? It's a chilling phenomenon known as rigor mortis. This is not your typical dinner conversation, but it's a topic that has fascinated scientists, doctors, and crime scene investigators for centuries. Rigor mortis, from the Latin meaning stiffness of death, is the post-mortem condition that causes a deceased body's muscles and joints to stiffen, a process that starts a few hours after death and can last up to 72 hours. This stiffening is due to biochemical changes in the muscles, a fascinating yet unsettling natural process. In the realm of forensic science, rigor mortis is a vital clue. It assists investigators in estimating the time of death, which can be crucial in solving criminal cases. Similarly, in medical studies, understanding rigor mortis helps students comprehend the intricacies of human anatomy and physiology. As eerie as it may sound, understanding rigor mortis is crucial in several fields, especially in forensic science. To understand rigor mortis, we need to dive into the world of cells and see what happens when they die. Imagine a bustling city full of energy and movement. This is what a living cell is like. Cells are the building blocks of life, constantly busy with the processes of metabolism, the set of chemical reactions that sustain life. One of the key players in these reactions is a molecule called adenosine triphosphate, or ATP. What is ATP? Think of it as the currency of energy within the cell. It's made during a process called cellular respiration, which breaks down food molecules to release energy. This energy is then stored in ATP. When a cell needs to do work, it spends ATP, breaking it down to release the stored energy. Now, let's talk about muscles. They're made up of cells too, and they contract and relax through a process that is fueled by ATP. When a muscle cell contracts, it uses ATP, and when it relaxes, it uses ATP. It's a cycle that continues as long as the cell is alive. But what happens when life ceases, when cells die? The machinery of the cell doesn't stop immediately. Cellular respiration continues for a while, using up the remaining oxygen and nutrients. ATP is still produced, and the muscles can still contract and relax. But eventually, the oxygen runs out, the nutrients are depleted, and ATP production grinds to a halt. Without ATP, the muscles can't relax. They remain in a state of contracture, locked in place. This is what we know as rigor mortis, the stiffening of the body after death. It's a natural part of the process of death, a sign that the cell's energy stores have been exhausted. So it's the cessation of ATP production that triggers the onset of rigor mortis, a fascinating yet unsettling fact of life and death. Rigor mortis doesn't occur instantly. It's a process that progresses in stages. Our journey begins with the initial flaccidity. This is the stage immediately following death, where the body is limp and pliable, a state of relaxation, if you will, though a morbid one at that. As we move forward, 2 to 6 hours post-mortem, we enter the onset of rigor. The body starts to stiffen, beginning with the eyelids, neck, and jaw. This is the body's farewell performance, powered not by life but by the chemical reactions still occurring in its cells. 12 hours later, we reach the peak, full rigor. The body is at its most rigid, every muscle locked in place, a statue commemorating the life that once was. Finally, we arrive at the resolution stage, approximately 48 hours after death. The body gradually relaxes again, the rigor mortis dissolving as the decomposition process continues. From onset to resolution, rigor mortis provides an eerie yet fascinating timeline of, so, what have we learned about the chilling phenomenon of rigor mortis? Well, we've unraveled quite a few mysteries. To start, rigor mortis is closely related to ATP, the energy currency of our cells. After death, ATP production ceases, causing muscles to stiffen, a state we know as rigor mortis. This process doesn't happen all at once, but in stages. Initially, there's a period of relaxation, followed by the onset of rigor mortis, then full rigor, and finally resolution. Each stage has its distinct characteristics, and the exact timing can vary based on several factors. Moreover, rigor mortis is a vital tool in the arsenal of forensic science. It can provide clues about the time of death, helping investigators piece together the events leading up to a person's demise. While it may be a grim topic, understanding rigor mortis offers intriguing insights into the final stages of life's process.